The last section, we wrote a function that read a file, performed a calculation, and then we started using that function. What I'm going to do next is talk about one of the most annoying problems of working with functions and working with data, and that problem is how to handle errors. Just to illustrate that, right now we have this function, and we have this code. It's reading a data file and performing a calculation. One of the things that's going to happen is invariably somebody is going to execute this code on a file that has bad data in it. Let's say I change the file name to something called missing.csv. I'll show you that in a second, and I run the program. What's going to happen is the program is going to fail, and the reason that it's failing is it's trying to perform a calculation on data that it's not expecting. In this case, what's going on is that this missing CSV file contains data, but in some of the rows, there are actually missing columns, like a missing data value. There's one that's missing. Here's one that's encoded as NA down below. That is going to cause the program to blow up. You see it blowing up because it's generating an exception when it tries to do integer conversion. So what I want to talk about first is actually how to catch that error. If there's a possibility that the program can blow up and you want to deal with it, so you've decided that I want to ignore that or I want to catch it, the way that you do it is you enclose a block of statements with a try block. So I'm going to use a try statement, and then I'm going to use the except to try and catch a very specific error. Now, what's happening here is I'm looking at how the program is failing. Down here, it's failing with a value error. What I'm doing with the except is I'm telling this program that I want to catch that error, saying I want to catch a value error. And so I'm going to catch that. And then what you can do in the except block is provide maybe some kind of diagnostic, for instance. What I'm going to do here is maybe print out a message saying, hey, you got a bad row, and I'll print it out. The other thing that I'm going to do here is I'm going to make the code skip the rest of the calculation. One thing that's a little bit tricky with catching exceptions is I don't really want this statement afterwards to run if there has been an error. I mean, it wouldn't make sense for that to run. So I have a couple of ways to deal with that. One way to deal with it is I could put a continue statement in here. This is something that skips to the next line. It would skip to the next item in the row there. I could do that. Another way that I could handle that is I could move the calculation into the try block. That would be another option. I think I'm going to stick with the first option since we were kind of rolling with that. So what I'm doing here is trying the calculation. If it fails, I'll print out a warning and then just keep on going. So let's try that and see if it works. So let's save the program, see what happens. Now the program is running and you see it reporting information, bad row, and then it carries on and gives me the calculation. At this point, it actually brings up another question though. Why is this row bad? This is actually one of the tricky problems with error handling is that you get an error. You want to generate a useful diagnostic to the user and you've told them, yeah, you have a bad row, but you really haven't given them any information about why it's bad. So to do that, one of the things that you can do with an except statement is add this extra little qualifier here, this as error or as e or something, essentially the as keyword there. What's happening here is this will store the exception in a variable. Like the error will become like a variable that I can use. And if I were to print that out, it will give me more information. Like if I print out reason error, what's going to happen is you're going to get a more useful diagnostic. So if we run that, it will come back and say, okay, there's your bad row. And then below that, it will actually tell you the reason. Invalid literal for int, empty string. So doing things like this, usually a good idea with error handling. It's trying to be helpful to the user of this code, telling them, hey, you have a problem. Turns out that there's actually more that you could do with error handling. One of the problems with this code right now is it doesn't tell the user any information about where this is bad. Imagine that this was, instead of a file with 7 lines in it, this was a file that had 100,000 lines of data in it. We're not really telling the user where in this file this bad row is appearing. So one of the things that you additionally might want to do is maybe keep a row number of some kind. Like maybe you want to keep a row number, and then somewhere in iterating over this data, maybe you increment the row number, something like that. And then you will report that in the error message. Maybe you indicate a row number like this. And then the idea is that this will start reporting like the location in the file where this thing is bad. We have to look at our error message. It's telling me that I have a typo in my variable name. So let's go ahead and fix that. The fact that I made a typo there is going to be motivation for something I'm going to show you in about 10 seconds here. Okay, so now we have error messages telling me the row number and error message. The thing I want to talk about next is actually a very useful thing to know about in the context of generating errors. Turns out that keeping like a counter like that when you have a for loop, this is a really clumsy way to do that. Turns out a much better way to do this is to use a feature of Python known as the enumerate function. What I can do is I can modify the code to use enumerate like that. Turns out that what enumerate does is it will give you an extra counter that goes along with a loop, like a for loop like that. And it will just constantly update as you go through the for loop. And it actually saves me the trouble of having to worry about updating that. Like I don't have to initialize it. I don't have to increment it. The fact that I made like a typo in my code, I don't really have to worry about that. It sort of takes care of those details for me. So I'm going to use enumerate as an alternative. The start here is just indicating the start of the count. I'm saying I want to start with row 1. So let's go ahead and run that. Now we have a function. Essentially, we'll read through data. It will catch errors in the data and then report, hopefully, a useful error message back to the user, sort of saying where that took place, the reason why it failed, and so forth. So this is something that is very commonly done in functions where you'll write code, and then you do need to start paying attention to things like error messages and reporting things back to the user.